Hello everyone, my name is P. Lavanya, working as Assistant Professor in EC Department from Marri Laxman Reddy Institute of Technology and Management. Today we will discuss about operational amplifiers. Ideal operational amplifier or ideal op-amp. Operational amplifier is a direct coupled high gain amplifier which is used to amplify the voltage difference between the two input signals. So operational amplifiers having 5 terminals. First one is inverting input terminal, non-inverting input terminal, output terminal, positive power supply and negative power supply. Positive power supply terminal is plus VCC and negative power supply terminal is minus VE. Generally, amplifier is used to strengthen the weak signals. So here operational amplifier is used to amplify the difference between the two input signals. This operational amplifier can also be used for mathematical operations such as addition, subtraction, integration, differentiation, multiplication, even division also. So that's why this amplifier is called as an operational amplifier. So this is the basic symbol of a operational amplifier. So this operational amplifier is represented like a triangle which is having two inputs, positive input terminal, negative input terminal. Here this positive input terminal is called as a non-inverting input terminal and the negative one is called inverting input terminal, and it has output terminal and also it has power supplies, positive power supply, negative power supply. So positive power supply plus VCC and the negative power supply is minus VE. Here the output is given by AD into V1 minus V2. Let us consider V1 minus V2. It is difference of the two input voltages. Here AD is a gain, differential gain. So V0 is equal to AD into V1 minus V2. We know that operational amplifier amplifies the difference between the two input signals. Here it amplifies difference of the signals V1 minus V2. So the output depends on the voltage difference between the two inputs. V0 is equal to AD into V plus, that is positive terminal voltage, and minus V minus, it is negative terminal voltage. So where V0 is the output voltage, AD is the differential gain, V plus is the non-inverting input terminal voltage and V minus is the inverting input terminal voltage. This is about the symbol for the operational amplifier. Coming to for inverting terminal, let us consider the input voltage as V1 and for inverting input terminal, input voltage is V2. The differential voltage will be VD is equal to V1 minus V2. Differential voltage means difference of the two input signals, and the output voltage is given by V0 and the base currents are given by I0, I1 and I2, both are zero values. Actually, for operational amplifier, V1 and V2 are the input voltages. There are some currents which are entering into the operational amplifier, like IB1 and IB2. These are called as base currents. So these base currents are zero for operational amplifier. Why? Because operational amplifier having high input impedance. So it is having almost, for ideal operational amplifier, resistance value is infinity. So there will be no entering currents. So IB1, I2 both are zero. Therefore, V0 is the output voltage and is given by AD into V1 minus V2, where AD is the differential gain of the operational amplifier. So we know that V1 minus V2 is the difference voltage. We will represent this difference voltage by VD. So VD is equal to V1 minus V2. Therefore, V0 is equal to AD into VD. The output voltage of an ideal operational amplifier is directly proportional to the algebraic difference between the two input signals. The characteristics of an ideal operational amplifier. Ideal operational amplifier having different types of characteristics. First one is infinite input resistance. We have already discussed about the input resistance. So for ideal operational amplifier, input resistance Ra is infinity. Because of this condition, the entering currents will be 0 in the operational amplifier. It is denoted by Ra and it is infinite for ideal operational amplifier. This ensures that no current can flow into the operational amplifier. So here, because of I1 and I2 are 0 because of high input impedance. For ideal operational amplifier, input impedance is infinity. Coming to second point, infinite voltage gain. Gain for ideal operational amplifier is infinity. A is equal to infinity. Next, zero output impedance. So it is denoted by R0. So for operational amplifier, Ri is infinity and R0 is 0. It is 0 for ideal operational amplifier. This ensures that the output voltage is independent of the load current and op-amp can supply maximum current to the load without any voltage drop. Therefore, R0 is equal to 0. Coming to zero offset voltage. So offset voltage or offset currents are small variation of currents and small variation of voltage are called offset currents and offset voltage. Here the offset voltage are 0. The presence of small output voltage when V1 and V2 0 is called as offset voltages. That means when both the inputs are grounded, then also there is some voltage across this. So that voltage is called as an offset voltage. For ideal operational amplifier, the offset voltage is 0. Infinite bandwidth. Fifth one. The bandwidth of operational amplifier is infinite. In the ideal condition, bandwidth is infinity. This means that the operating frequency exceeds from 0 Hz to infinity. Next one is infinite slew rate. What is meant by slew rate? Slew rate is defined as maximum rate of change of output voltage with respect to time. So it is denoted by dV0 by dt. This is about slew rate. And seventh one is infinite common mode rejection ratio. So common mode rejection ratio is defined as it's a ratio of AD by AC. AD is the differential gain and AC is the common mode gain. So it is a ratio of differential gain to the common mode gain. Generally, common mode rejection ratio means it is the ability to reject a common mode signal. Common mode signal means suppose we know that operational amplifier is having two inputs V1 and V2 and the output is difference of V1 minus V2. Suppose we give 5 volt signals to this one, 5 volts to each the terminals, the output will be 0. That means if you give common signal, then the output will be 0. For that process, we always reject the common signal. So common mode rejection ratio should be high value. For ideal operational amplifier, common mode signal is infinity. So simply we call this as CMRR is equal to AD by AC. It's a ratio of differential gain to the common mode gain. For an ideal op-amp, the CMR is infinity because common mode gain is 0. This means that op-amp amplifies only the difference between the two input signals and completely rejects the signal that is common to both the inputs. So we know that operational amplifier amplifies difference of the signal. So whatever the signal is common, then it rejects the common signal. These are about the characteristics of the ideal operational amplifier. First one is infinite input impedance, infinite voltage gain, zero output impedance, zero offset voltage, and infinite bandwidth, and infinite slew rate, and infinite common mode rejection ratio. Except the output impedance, all the factors are infinity for the operational amplifier. Next, virtual ground. Virtual ground is a condition in an operational amplifier where the inverting input is maintained at ground potential even though it is not physically connected to the ground. Suppose if you see the figure here, operational amplifier positive terminal. Positive terminal means non-inverting input terminal. Non-inverting input terminal. Here non-inverting input terminal is grounded. So here let us consider voltage at this node is VB and voltage at this node is VA. When non-inverting input terminal is grounded means here VB is 0. It is grounded. So coming to VA, here we have a voltage at node VA. This node voltage is also becomes 0. It is actually not physically connected to the ground, but other node is connected to the ground. That's why here VA is also becoming ground. This is called virtual ground concept. This occurs in an operational amplifier operating with negative feedback, where non-inverting input is connected to the ground and the op-amp has very high open loop gain. So this is called as a virtual ground concept. Without directly connecting to the ground, other terminal is connected to the ground, automatically this value becomes 0. Here VA is equal to VB is equal to 0. This is called as a virtual ground. For an ideal operational amplifier, we know that A is equal to V0 by Vi. So for ideal operational amplifier, we know A is the gain here. Gain is nothing but output voltage by input voltage. Here for input voltage, Vi is in operational amplifier, difference of the inputs, so V1 minus V2. So A is equal to V0 by V1 minus V2. So for ideal operational amplifier, we know that gain is infinity. Let us substitute value here. Input voltage is V1 minus V2 is equal to V0 by gain. So this value will be 0. Therefore, V1 minus V2 is equal to 0. Here V1 is equal to V2. So even though it is not physically connected to the ground, this is called as a virtual ground. Here both the input voltages are 0. So therefore V1 will be 0 and V2 will be 0. When V2 is directly connected to the ground, then V1 becomes 0. When V1 directly connected to the ground, then V2 becomes 0. This is called as a virtual ground concept. Coming to the DC characteristics of an operational amplifier. The DC characteristics of operational amplifier describes its behavior when they are connected to DC, direct current signals, or constant input voltages. These parameters determines the accuracy and stability of the operational amplifiers in practical applications. So, DC characteristics of operational amplifiers are input bias current, input offset current, input offset voltage, thermal drift. Input bias current. So, input bias current means we have already discussed about the base currents. We have already discussed about base currents. So let us consider V1 and V2. Here at the place of V1, entering current will be, let us consider I1, IB1 or IB plus, and here for V2 the entering current will be IB minus. So the input bias current is given by IB is equal to, it's a IB plus IB minus by 2. Ideally no current, we know that ideally no current flows through the operational amplifier. So practically a small steady state current flow at both terminals to the bias the internal transistors. It is defined as the average of the input currents. So average of input base currents is called as a input bias current. Input offset current. Due to internal component mismatches in the differential input stage, the two bias currents are not perfectly equal. It is the absolute difference between these two currents. So input offset current is represented by IIOS. It is the difference between the base currents. it is the difference between the two base currents. We know that for ideal operational amplifier or any operational amplifier, the base currents are 0. But because of components mismatching and all, there are some currents available at the base. So these is called as a input offset currents. Coming to input offset voltages. Similarly, like input offset current, there are some voltages. Even though when both the input voltages are grounded, means V1 is equal to 0, V2 is equal to 0. But there exists some voltage. So that small difference voltage is called as a input offset voltage. When both inputs are grounded, an unintended output voltage may exist due to internal imbalances. Input offset voltage is a small differential DC voltage needed to drive the output exactly 0. So it is small voltage available at the inputs is called as an input offset voltage, and it is represented by VIOS. Next, thermal drift. So the parameters like bias current, offset current, offset voltage vary with changes in temperature. This drift can cause baseline wandering in precision DC circuits. So this is called as a thermal drift. It is nothing but because of the temperature variations, parameters like bias current, offset voltage will vary. This is called as a thermal drift. Till now we have discussed about ideal operational amplifier definition. It is nothing but the ideal operational amplifier is a direct coupled high gain amplifier which is used to amplify the voltage difference between the two input signals, and it has 5 input terminals: inverting input terminal, non-inverting input terminal, output terminal, positive supply and a negative power supply, and it is used to do some mathematical operations like addition, subtraction, multiplication, differentiation, integration and all. Next, there is a symbol for the operational amplifier and output voltage equation. V0 is equal to AD into VD. VD is the differential voltage, AD is the differential gain, and the characteristics of the ideal operational amplifier in infinite input resistance, infinite voltage gain, 0 output resistance, 0 offset voltage, infinite bandwidth, infinite slew rate, and infinite common mode rejection ratio, and the concept of virtual ground. Without directly connecting to the ground, other terminal is also considered as a ground. That is called as a virtual ground concept, virtual earth or virtual ground. Here VA node voltages will be 0 in this virtual ground. Next, the DC characteristics. When DC supply is connected to the operational amplifier, what are the characteristics? So input bias current, it's a defined as the average of base currents, and input offset voltage, and input offset current, and thermal drift. These are the DC characteristics of operational amplifier. Thank you.